Hey everyone, thanks for joining us on a Friday afternoon. Um, I want to introduce Jared, my co-host here with BIMTM. Jared, you want to take it away and give us a little bit of a background about yourself?
Sure. And actually, we'll wait a minute or two here just to have more attendants come in as they do. But as kind of as a before we start here, um, and we got a lot of good topics coming up, and want to topics a good topic with a lot of great content, and we want to have this be as interactive as possible. I know with the way that it's structured, it's not necessarily going to be um, uh, as much of a roundtable as I'd like, but we definitely want your questions throughout the webinar, and we'll be working on answering them throughout, and then also be really interested in having you share your experiences as well with some of the rework and the types of things that you've come across and ways that you've improved your workflows here. So
Yeah, that's great. Thanks, Jared. Yeah, I think the chat looks like it's open. So if you want to chat amongst yourselves in the chat, and then there's a Q&A portion that you can shoot your questions in, and that'll come directly to us. And Jared and I can answer your questions directly there.
excellent. And as we get through the presentation, then at the end we'll have a full Q&A. So if we did not address your questions kind of in the middle as we're going, then we'll tackle those at the end. So all right, well, we're a little over a minute into it here, so we'll get it started. So thank you everybody for joining. My name's Jared Sutliff. I'm one of the co-founders and brand ambassador of BIM Technology Management. You can see my little eagle friend here on the screen. A little bit about us. We're 100% US based BIM consulting firm, trusted partner for the MEP trades, AEC, construction managers, and general contractors as well. We do modeling, coordinating, clash detection. We'll even help streamline your BIM process and just help you get on your own 2 feet and uh, become what you're looking to do in the long run as far as BIM goes. Myself, I've been in the industry for a little bit over 18 years. My expertise is in the electrical systems, and I'm knowledgeable-ish in mechanical plumbing and structural and construction management as well. As we said, make sure to use the chat box for any questions that you have or any comments and your experiences as well. So with the Zero-Rework electrical closets, this checklist, one of the things that we want to emphasize here is it doesn't matter how fast you model if it's thank you emoji icon. I won't say that out loud, but everybody knows where I'm going with that. And amazing tools like Evolve MEP are fantastic, but that doesn't fix bad input. If we model without answers, we're just going to be modeling incorrectly faster with these tools. So, what is a zero rework electrical closet and why does it matter? So, I don't know if anybody here has seen me before. I've been in a couple of videos, but surprise, I'm not perfect. I've made a lot of these assumptions and not utilized checklists like this and before and made these mistakes. So learn from me. And that's why we're doing this presentation today. We're not teaching you how to draw in Revit. It's about what needs to happen and what information you need to track to be successful and to make this a zero rework electrical closet. So the checklist that we have here is our guardrail. It's going to force the right kind of conversations before you begin modeling, before prefabrication begins, before it gets sent to the field. So we want to make sure that we're reviewing the detailed information. We want it to be buildable, prefab ready, check the submittals, any of the nuances and notes in the construction drawings themselves. So phase one here, the important stuff is knowing the information before you start modeling. So we want to gather, we want to verify, we want to understand. So we're going to get the construction documents, we're going to review those construction documents. We want to get that information, share it with the other experts in the room, the prefab team, the field team specifically, because they're going to use the construction documentation for reference. They're ultimately responsible for the final build, making sure it matches the design. And if we begin modeling before we have these key decisions identified, and gets part back to my experience, you're gonna model it once. Oh, we've got a delay of information, so now that initial modeling is broken. Oh, we got updated and approved submittals now. Well, now that changes our layout again. And then it gets into the field, and then the field goes, well, we didn't have any input, so we're going to do it our own way. So they fix it again. Well, for just one electrical closet, now we're modeling it at least 4 different times. And everybody here knows that, well, that's not the right way to do it. The idea with BIM is pre-planning, execution, flash detection coordination, making the information available to everybody. So before we model, like I said, we'll gather the information, meet with the field and the shop to understand how it's actually going to be built and eliminate any assumptions that we have. So some of the details in the construction documentation that I have on the screen here is we have our one line, we have a duct bank detail, and we have our feeder or wiring schedule. And I have these on the screen. I'm sure if anybody isn't familiar with these, this is essentially the brain and the spinal cord, the one line of your electrical systems. And then, each of the nerves that branch out from there is going to be your feeder schedule. So it's what size wire, what size conduit, what type of material it is. All of this is very important. And as we get a little bit later in the presentation here, we'll see exactly why that can affect your modeling and your information that we want to make sure we have those answers beforehand. So what I'm going to do as well is I'm going to shift over to Revit here. And what we have here is, some of you might recognize this. This is the Evolve sample electrical model. And I did make some adjustments to it. So this model is our fully signed off model. I mean, this is before we made a lot of assumptions here. So we've got our gear, we've got our feeders, we've got some underground overhead, clearance zones, panel names, etc. So we have this, it's fully signed off, we're all set and ready to go, and it looks fantastic. But as we'll see, we're going to have a surprise rework party and everybody's invited. So we want to make sure that we avoid a lot of these issues. And we're going to jump into phase 2 here and start talking about what we need and why it's important to engage with these questions early. So phase 1, pretty straightforward. It's the construction documentation review. Everybody does this, right? Or should be doing it, but you might miss some of the nuanced details. And phase 2 here is where a lot of teams will just jump right into modeling based off of the design. And what we're saying is pump the brakes a little bit. We want our modeling to reflect the real submittals, the real gear, the real field intent, and how we can utilize it for real prefabrication. Now, If, and I'm going to have this with a gigantic asterisk, if you need to model for coordination reasons before we have some of these answers or a lot of these answers, you can do a generic zone that encompasses your worst case scenario, because then at least you're telling the other trades, you're telling your GC or CM, this is what we anticipate we're going to need, but we don't have the answers yet, so we're not going to waste our time with minor detail modeling. That's not the point of today's webinar, but that is an option that you can do as well. And the goal of phase 2 here is to have the model reflect real world conditions, actual equipment, material types, sizes, locations, means, and methods. And when we're in the equipment and prefab input, this phase 2, we want to sit down with our field team. We want to sit down with the prefab team. We want to have the BIM project lead involved with this, so we can look at the construction documentation here. So in this case, we've got all of these lines here is the field preferred route, or how they were connecting the equipment based off of the one line and the locations in the engineered drawings. They also went through and reviewed to make sure that our feeders are correct. So they also put the information from the feeder schedule in here as to what it is. And the notes that we have on our drawing as well is just so everybody's looking at the same document, everybody's looking at the same information. We can track notes of our discussion that relate to our checklist, and then we can compile all of this and share this with our teams. So important things from the field is we're going to be using aluminum conductors for all feeders instead of the copper feeders. They want panels to be built in shop, provide the standard rack build and a trough above and below. So now this is what the field is looking for and expecting, and it's involving prefab. And it's also involving BIM because we can model and detail it correctly. They're talking about the material types for overhead and where we want it to be. We're going to be high and tight because we want to be able to get in and install early, and then we can just get out of the way. We can pull the wires and be ready to go when energizing the equipment and stuff is going to begin. Underground feeders coordinate. It's going to be schedule 40 with rigid stubs for 400 and larger feeders because of wear and tear on the PVC. I'm not going to get too deep into that, but I can talk about it until next Thursday. So, and then we've got the prefab team. How are they going to be breaking up the build? Because we're not going to be able to send a 100-foot section of racking. So underground, they said we'll be able to put it in 20-foot assemblies. We can put it on a truck, deliver it. Overhead, we're going to have unistrut 8-foot spacing with 10-foot assemblies. And then any elbows are going to be loose to have the field install it together. So, and then from a BIM side, we're going to be focusing, it came from the spec. We have a maximum of 270 degrees of bends between pull points. Okay, great. All the field wants all J boxes to be straight through. So these are a ton of the questions that, as we're thinking about it, it's going to save a lot of time downstream coordination, and all of this information is going to flow like a river from one end to the other and help prevent us from having to go back and do this again and again and again. So now we're getting into phase 3. And phase 3 is going to be, what do we need to do before we start modeling? And when we're doing this modeling, as somebody who graduated with an art and design degree with a focus in 3D modeling and animation, I can make anything happen. I can have a bus turn into a dolphin and fly to the moon. Doesn't mean it's real. Doesn't mean it can actually happen. So even though we're doing the 3D modeling and designing, we want to model with construction logic. We want to show real openings. We want to have real equipment spacing, real routing. We need to follow grouping of feeders so that we have those groups, and we'll see that in the upcoming feeder schedule example again, because they need to stay together. Engineering reasons I'm not going to get into. And then also we want to model how the field will install it. And the collaboration between BIM, the field, and prefab, getting them involved early, getting their input, they're going to be invested in the process and in the project. Ultimately, it's their build, it's their expertise that's driving this train. I'm not an electrician, so what I know is from what I've seen and learned. Um, but I'm going to leverage their expertise. I want them to say, this is exactly how we're doing it, and get their buy-in, because then when it's time to review the prefab drawings or the sign-off drawings, there are not going to be questions or a lot of changes at the end. And then the shop can start planning procurement. They can start planning staging. They can start planning scheduling with the other jobs and the other things that they have going on in the shop. And having a weekly check-in at this modeling stage as well builds rapport with the field team, with the shop, and the relationship. So we're all working on this for the same reasons, and ultimately for the same end goal. So a couple of the things that I've run into and has caused a lot of heartburn and headaches is modeling without the equipment submittals. And so I'm showing the equipment submittal, and yes, this is a very extreme example because, well, I want it to really hit home. So this example from the base model, the size of the equipment got wider, deeper, and taller. So if we were coordinating based off of the engineering, now our room is way too small. So we've had to relay it out and then relay it out and relay it out again. And in a handful of my projects, we ended up redesigning even the smaller tertiary closets 3 times during the coordination because of a released submittal that wasn't approved. Then it got changed. Then we had to double the panel. And once again, not having the information early is a hugely important aspect of why we have this checklist. And so now this example that we have, the equipment submittals. So our quote unquote perfect signed off model, now all of a sudden, as you can see in everything that we have in red here, is no longer that. Our equipment now matches our widths and our openings. So now our conduit don't hit our openings in our equipment. Our gear is much larger than the room. Our working clearances now interfere with other equipment in the room. So having that knowledge and that information before we go ahead and model and all of our other systems in here is super important. And in addition to that, the notes on the drawing are as important as our submittals as well. So if we missed information on our drawings here, you can see our duct bank feed details, our on-center spacing, and also our spare conduit feeders are a part of the answers that we needed, and we just jumped into it, and now all of a sudden we're sitting here holding our hands and wondering how we're going to make this happen. So in our details, we can see that our center spacing is 8 inches minimum, typical for a duct bank. And then also our additional note is if we just look at our feeder schedule, it's a series of six, 400 kc mil in a 3-inch conduit, and then an MF ground, plus two 3-inch conduits as spares. So back into our model example, we have, well, we're missing our spares here. And look at our center on center space. So I'm going to go into this section that I built so that we can see just how drastically this changed from the original layout and design, because I'm guilty of it. I've missed those small little notes before. And as you can see, it really has changed things. So it changes our underground support for a prefab. It changes our width and our height of our rack system, which can also negatively affect the other underground coordination with plumbing or mechanical, structural as well. So if we have an opening in a foundation wall that has already been poured, well, now it's not going to fit.
Hey, Jared, I'd like to just chime in if you'll allow me here. There's
Absolutely.
A great point that you brought up earlier. And, we started off the discussion with just making sure that you have very good information. You have all your submittals, you have everything you need out in front of you. And, there's a lot of details. There's a lot of variables that go into this. And I think the piece that's absolutely critical there is getting your field teams on board and participating in this process. Because at the end of the day, they're the ones that are going to build this, right? We don't coordinate in a vacuum. We're essentially designing something for construction, but ultimately we're passing this information off to our construction teams. And we need to make sure that what we do is in line with them. I think the second piece there is getting multiple eyes on this process. Like you said, there's notes and there's details, there's structural details, there's a lot of information flying around. There's a lot of meetings that are happening that may not always pertain to you, but ultimately each one of those pieces interact and play with everyone else, right? If there's a structural detail that you missed that isn't necessarily in your construction set, but your superintendent sat in on a meeting and is aware of that information, bringing them in and getting their buy-in ultimately just brings more eyes to the situation and can allow them to give you feedback, give you input.
Exactly.
One of the big pieces that I like to add to my title block is a note that says drawn by and approved by. Right. So at the end of the day, that approved by stamp ultimately isn't coming from you as the coordinator or the drafter. It's coming from the person that's going to install it. And that's kind of the last final check on my list to ensure that, hey, I've done all the steps, all the things that I know to do, that I'm privy to. I've consolidated all the information that I have and applied it to this drawing. The next step for me is to go get my buy-in from my project manager or my superintendent, or somebody that can go in and just give an extra pair of eyes to this situation. Because like you said, Jared, none of us are perfect. I'm guilty of it. Is missing these notes or missing a structural detail or realizing, there's been a change in the structural plan and all of a sudden there's a footer next to one of your windows and you didn't account for it in your original modeling. And maybe you didn't get a model update, but that structural detail has been released in your contract documents and you missed it. Like those things are common. And so getting your field teams buy-in and getting a second pair of eyes on this to help QC the process and ultimately share the responsibility of the load. Because at the end of the day, if your drawing set doesn't depict exactly how the field team's going to install it, they're going to figure it out. I've never been a part of a project that hasn't been built, right? But ultimately, we want what we model in to match what our field teams are going to install. So thanks for letting me chime in there.
no, those are a lot of great points. And construction has happened and buildings have been built long before BIM was involved, and they will be able to continue in doing it without us. Now, that being said, BIM is a tool that, used improperly, is useless. And doing BIM for BIM's sake is also useless. If we're not utilizing the information to help streamline flows or understanding of projects or capturing details that were missed by ourselves or the field team or anybody, it's just a waste of effort. We want to do this with intention, and having this checklist is bringing that intention to the forefront, getting those answers once again early. And the other thing is the field team will install it however the hell they want to do it. If you're saying it has to be this way, well, if you've never built it or you don't have that understanding and that rapport with the foreman or the PM or the super, they're going to be like, yeah, okay, nerd, you don't know what you're talking about. Where, and I've experienced this multiple times firsthand working with new foremen in my career. And just having those initial conversations with them and letting them know that, hey, I've got 15 questions that I found in the engineered drawings. It's this question on this page, on this detail that correlates to this page in this electrical closet. I need to know how you want to handle this. Then all of a sudden they're like, whoa, wait a minute. You know what you're talking about. You're looking at this in a way that's helping me, so I don't have to spend nights and weekends pouring through these drawings because I'm still finishing up another project as I'm getting started on this one. That builds that relationship and that understanding, and then they'll be willing to work with you and help you learn more. And with my background in art and design, my first big project that I did by myself, the first thing I did talk to with this new foreman, I said, "Hey, I'm an artist. I'm not an electrician. So I want you to explain this to me like I'm five, and I want to learn from your expertise and all of the thick skills that you've learned in your career, because that's going to help me help you help this process." So yeah, we'll jump back into. So we talked about the drawing notes here, why that's important. Um, let's see here. So then, and do we have any questions from the audience or any observations from the audience before I get back into the next phase that we're going to talk about?
No, it looks clear now, but just a reminder to everyone online, feel free to use that Q&A section to drop us a message, and I'll flag Jared and we'll bring it up if it pertains to what we're going through actively. Otherwise, we'll have a little Q&A section here at the end that we'll try and get to your questions.
Perfect. All right, so we'll jump into the phase 4 that we have of our workflow here, and that's the prefab validation portion. So in addition to getting those questions answered early, having the knowledge before we start modeling, we also, it's vitally important to have the shop be a part of this, because no different than the field is ultimately responsible for the final install, the shop is responsible for building the translated three-dimensional model into the physical object in the real world. So a lot of the things that we want to do with this is fly the model with the shop and the field crew. Why does that matter? Well, because then we can see the whole picture and we can start identifying, oh, this area is going to work out fantastic for prefabrication. This area isn't. So you've got the modeled information, so we can, instead of doing spool drawings for the shop, we can create just an installation drawing that gives the field team everything they need: size, bottom of conduit, um, size and type of unistrut, length of rod, bill of materials for that, so that they can build that in the field. And with flying the model and validating with the field and the prefab, we can confirm the breakdowns then. We're, once again, if we go back to our pre-planning and looking at the drawing with the layout, okay, we know all of the unistrut is going to be at 8-foot spacing. Okay, that's the modeling. Now we can review that. We're doing 10-foot assemblies, so we know we're going to break it here, we're going to break it here, we're going to break it here, and how those builds are going to really work out. And then we can also adjust any modeling needs and spool breaks before the sheets are made and the details are finished in the model. Because if we spend the time putting all the dimensions and the annotations on those drawings and produce it, and then the prefab shop looks at it and goes, well, we can't do it that way for these reasons. Well, now we're going right back to remodeling something where if we've got our checklist and we ask the questions early. Now we know that, and then this phase 4 validation is just confirming what we already went through. Maybe they got information now where getting the corridors are tighter, so you're not going to be able to swing a 10-foot rack into the electrical closet. So, okay, well, now how do we handle that? So we're identifying these before we create the spools and the sheets, so we can make it happen, make something work for everybody, and get it into the model. And so we're also asking, can the shop build this breakdown without having to re-engineer it? Can it be shipped? Is it a weight that isn't going to hurt people? Anybody that's worked in electrical knows just how heavy RMC is versus EMT. So rigid conduit versus regular conduit. So those types of considerations are hugely important as well. And talking about the conduit type there with RMC or EMT, having the correct modeled components is just as important as asking the questions. If you have the model, if you have the answer to the question, but you're in a hurry and you model it incorrectly, well, now we've got a lot of rework again. And cough, cough. I've been guilty of this. Incorrect conduit type. So we looked at the underground needs to be Schedule 40 PVC, overhead needs to be EMT in this case, not always. So verify these requirements and the type of modeling you're doing. So in this case, you can see my tags here. Whoops, I wasn't paying attention. I modeled the underground with EMT, or in this case, generic default conduit. And I have my overhead as RMC, not EMT. And like I said, I've done this because I hit my keyboard shortcut and I didn't change the type of conduit that I was utilizing, modeled an entire rack system, did parallel conduit runs, and then realized, crap. Now I got to go through, highlight all, change it all, make sure the elbows are correct. Is my spacing correct? Did that change anything downstream? You can see it snowballs. And that's why it's important to have the information, but also work with your technicians, as this is what we always do every time, no ifs, ands, or buts. When you're drawing conduit, the very first thing you do, what am I modeling and what do I need it to be?
Hey, Jared. Brian's got a question, and I think it's pretty in line with what we're talking about here. With the question is, with so much data info involved, um, and with more expected, I think the expectations are increasing every day. It seems like how many people do we see coordinating and detailing teams to handle all of this? So let's assume like a mid-sized level project,
Mhm.
commercial project. How many people on the VDC coordinator, drafter, detailer? What does that team look like, and how big, in your opinion?
Um, so that would depend on the scope, the level of development needed for the project, and the specific trade as well. Um, I would say schedule is also very important too,
Yeah.
because if there's the proper amount of time built into it, then we could get away with maybe a team of uh, three or four on, let's say, a 200,000 square foot project. Um, and if you've got the right team members in place, the right project lead, then you can have one team member working on feeders. You can have one team member working on branch. You can have one team member working on lighting and equipment. And then that way they're, I'm going to say, staying in their lane, but they're focused on one aspect of the project where that they can become very knowledgeable on and very efficient at modeling, QA, QC, making sure the right information is entered into the model based off of the checklist. And so it depends on a lot, availability, and this even gets into I would say the non-answer to your question is it's kind of like the field team, right? So they'll ramp up as time needs, and BIM can potentially ramp up and down as needed because I may be on a project where early on I only need to spend 16 hours a week on it. But then as we're in the depth of coordination and we're coordinating four different zones at the same time, I might need to spend 40 hours on it. So there's uh, my apologies for the answer non-answer, but it depends on how many systems you have. It depends on the size of the project, and it depends on the knowledge base of the technicians that you have as well.
Couldn't agree more. Thank you. And yeah, I would encourage you, even in this process, regardless of the size of the team, is get your project team on board. Recruit one of your PEs to
Mhm.
go hunt submittals down for you, or coordinate between the shops as far as when deliverables need to show up for field install, or talk to your superintendent because maybe the rack that you're building isn't going to fit in the door, so maybe they can leave the wall
Mhm.
out for you, right? Like
Yep.
those are a
Yep.
lot of little moving pieces there. So recruit your team, realize that you're just not, you are a part of the construction team, your
Mhm.
field team, you're there to augment and support them. They can also work in reverse and support you. So
Mhm.
the more team atmosphere you have, the better off you'll be. And realize that, yeah, you probably can't do it all alone by yourself. Um, we do have one more question, and I don't want to throw you off too much, Jared. This
No,
one's
go ahead.
about submittals, if you're good with it.
Yeah.
The question is, what strategies do you have to get switch gear submittals early? I think this pertains to like a design build where you really don't have any actionable information, but you're required to
Mhm.
get it into the model. Um, do you have my recommendation or my first thought is, these submittal packages don't change all that much project to project. Your PM probably has an older project that they do have the submittals for, and maybe you can pull that
Mhm.
from there. But I'm curious, Jared, what recommendations do you have for that?
Well, that's my recommendation. You do make a good point because a 400 amp panel with 42 breakers. isn't really going to change all that much.
Right.
Gear can change quite a bit, and depending on the height of the gear, that can change a lot of things as well. Like in our equipment submittals, we've got our radiuses of our coordinated racks. Well, they're not hitting the top of the gear anymore. We can't actually install this. So that's something that we need to think about. And that's where having the submittals, the approved submittals is important. Getting a preliminarily approved submittal or uh, drawing a blank on the actual terminology, but like an early release of a submittal can at least give you a good idea. But I would say, similar to developing your relationships with the shop, with your field team, the GF, having a good relationship with the PM and an understanding of why this stuff is so important will give you the leverage and the understanding of, oh, if I don't have this, I can't make progress. So then the PM would understand that it's a critical path element to push harder on to get at least a preliminary submittal. And, hopefully, if the internal guts change, that doesn't necessarily affect the modeling of the overall equipment layout and conduit. It might change some of the breaker sizes or fuse sizes or those kinds of things, but it won't affect the overall length, width, height, and entry locations of your equipment. So having a good relationship and the understanding of why it's important, and maybe having a PM that's able to push a little harder on the suppliers to get you that information in a timely fashion, could be a really good win there.
I think back at that previous slide that you have,
Mhm.
money is oftentimes a good motivator.
Money is
Uh,
always a good motivator. Yes.
I've ran into an issue where I couldn't get my radius 90 down to the top, so we had to custom order and manufacture a top hat for our
Yep.
gear so we could just go in and 90 inside of a box.
Yep.
That custom top hat ended up running us probably, I think it was like 15 grand.
Mm-hmm.
So, go to your PM saying, hey, I need this. The downside of the potential is a significantly added cost to your equipment as a result of not getting this in early enough.
Correct.
So sometimes that might help further the conversation or get the ball rolling
Mm-hmm.
once you start waving around dollar signs. So
Yep. Yep. And actually, a way to kind of bring it back to, how do you deal with it if you don't get the submittals is, like you said, reference a prior project. And if the manufacturer is the same and you've got a submittal that has all of the sizes of the various amperage of equipment, then you can at least utilize that as your worst case scenario. Because if our equipment gets smaller, well, that's going to make things a lot easier. Yeah, it might extend our conduit a little bit, but if we oversize this by, say, 6 inches too tall, 6 inches too wide, yes, that will affect your landing zones potentially, but at least that way you're modeling with the worst case scenario. And this is stepping out of the intent of the webinar, so I do apologize and want to reel it back in here a little bit, but that at least could get you a preliminary starting point, but then also have an asterisk in there and just say, hey, you know, make make a note on your working view that, you know, this is preliminary, right? Need info to proceed. And then that way, if we have these notes on our drawings as well that are being reviewed with the field team, like it's right here. It's this isn't finalized. We need the final information to finish this up. All right,
Thanks,
I know
Jared, for
we're at about 45 minutes here, so I want to get through the last couple of slides, and then we can get into the Q&A. One of the other things that we talked about is the aluminum conductors, or the conductor material type and what that'll change. And this is the wiring, the feeder schedule, wiring schedule of this sample project. And what I've highlighted here is we modeled everything as copper feeders, but because of the review and the value engineering, some of our sizes have changed. And any of the ones highlighted in red here are where the conduit size actually increased when we had to go, when the change was made to the aluminum feeders. So it may not be that big of a deal, but now we've got our spacing issues, we've got our coordination issues, our rack sizes are going to change. And in certain instances as well, the size of the conduit doesn't change. So that's something where it's not always going to be different. It can be, and oftentimes it is, but it's just something to be mindful of and aware of. And one of the projects that I was on as well, all of the PVC feeders based off of the schedule were 3.5-inch conduit. And working with the shop after we had the installation drawings done, they said, well, yeah, we can get 3.5-inch PVC, but the lead time is longer and it's more expensive than 4, so we're just going to make it 4 inches. Oh, well, are you sure? Like, this hasn't been approved. And so it was that learning that, if there are standards, box sizes, like what are the standard box sizes that your supplier has on hand that you can get? That's information to know, so you don't have a random size that needs to be a custom built $15,000 box. So those are types of things that are, be mindful of in the checklist, and those types of things that are good to bring to the table early and track and have an understanding of the build. So last couple of minutes here, phase 5, field installation verification. I think we all know we've all worked with field installation, and you go out there and you're like, well, that's not what we modeled and coordinated. And because we didn't involve the field team, and this one in particular, this checklist is for, okay, we've got everything modeled, it's set and ready to go. Field team, we want your last review, your blessing, your sign off on this model. We're going to fly it together. We're going to look at the documentation. We're going to make sure that everything is good to go. And the main important part about this is, before it's released, you want your field team to answer this question. If you and your crew showed up tomorrow with the material, can it be installed exactly as drawn? And if the answer isn't a confident yes, it's, we're going to be bouncing back and forth, or material is going to be prefabbed and supplied that they're going to take apart and build separately anyways. Now that defeats the purpose of everything that we're trying to accomplish here. And the last slide, the last part of the model that I have here is proper clearances are hugely important. I ran into this one on a number of projects where all of a sudden our closet wasn't big enough. And I believe, based off the research, the NEC 110.34 talks about the clearances and very specific distances of clear space in front of equipment based on voltage, based on a grounding wall behind, and those types of things. And with the original layout here, with our switchgear here, in the original coordination, these were only 3 feet long. In actuality, it's a 5 foot working clearance for this equipment. And as you can see in these two instances, our gear no longer fits in this room. So the last thing that I have here is our flying of the model, having Navisworks available to the field team and having them know how to use it, or flying this with the shop is an important aspect as well. And the information and the data that comes along with this, because we're putting the I in BIM here, we can have this easily accessible for our field teams with the quick properties in Navisworks specifically. If you hover over any of these elements, you've got to get this set up, but it pops up this little window that says, all right, this is a 3-inch EMT. It goes from MSB to HV1B. The bottom of conduit is 10 foot, 2.5 inches. And the trade size, once again, here is 3 inches. And same thing, if we go into the underground, I think this was modeled as, yep. So a 4-inch schedule 40. And the properties look like it's not quite right because the diameter trade size, even though it's a 4-inch PVC, says 3.5. So, verifying that information is crucially important.
Giving your field teams access to the model, and especially in the underground phase, identifying the elevation for them, will save a lot of questions.
And also knowing it, are we going, -3'4" from what? So maybe they want an elevation from 100 or whatever the baseline is on the job site, so that they know, because -3'4", like I said, from what? Well, that doesn't help. So knowing that information and what they actually need in the field is important to include within our project here. So, and last but not least here, the BIMTM workflow that we have that deals with our checklist here is, understanding the documents, the submittals, getting field input, prefab input, then modeling, doing those validations and verifications, then you can release it. And that's how we can get to a Zero-Rework workflow, in this case, specifically for an electrical closet, but that will significantly reduce any rework that we have within any of the projects that we are working on here. And like tools like Evolve MEP Shine, when we have that information, when we start with clear answers, and those types of softwares help us move faster without utilizing the field as our quality assurance. So we will be able to, with the last 7 minutes here, answer types of questions that you all may be having here. So
it looks like we have one question on the board here. Do you want to remind anybody, if there's any questions that you had during the presentation, please throw them in the chat and we will get to them. We do have one question on board. It says, do you find that Evolve Shop helps open up the communication with the field? The intention behind Shop is to help communicate or streamline the communication or back and forth between your prefab shop. So unless your field teams had access or had a way of looking at what was submitted through there, I don't believe typically that would be the workflow. However, it does augment or change a part of or a section of that communication process. Jared, what would you recommend, or what have you found in communication with your field teams? What works best for you?
Well, to to touch base on the Evolve shop piece, the information that the shop needs and utilizes is going to be different than what the field needs and what's important to the field. So what we've uh, developed and workflows that work for us is having a weekly touch base with the field. Get them involved early on, as we've been talking about the whole time here, is review your drawings, review the model with the field team, and get that weekly meeting scheduled and have the most important, hardest hitting questions there. Give them a heads up on the questions you're going to ask so they've got some time to have an answer at the ready. So these meetings are efficient, effective. You can get the information, the answers from your field team. You can get it back into the model. You can revisit it. They can sign off on it, and you can go from there. So having that precise communication with the field team is hugely important. That reoccurring meeting every week, maybe more if you need it, depends on the project, but that will develop that rapport and that relationship with that foreman, with the field team, so that they know without a doubt you're there to help them make their project on schedule, more profitable, and you're not just another pain in the ass that they've got to deal with on their project.
Yeah, that's great advice. I think that one of the bigger key takeaways here is communicate and build rapport and relationships with your prefab shop, your field teams, your project managers, your trade partners, your general contractors, design team. The list goes on and on, right? So that's great advice, Jared. Thank you.
Yeah, and look at any of the conversations that people have had with you, and who are the people that you respect, and how do you work together. Think of it from that aspect when you're working with your field team, with the shop. If you don't have that rapport, try to figure out what their personality type is, and be able to connect with them. And just like anybody that you're connected with in any aspect of your life, when you're excited to work with them, right? And that makes the process that much better.
Fantastic. We've got a couple more minutes here. Got a question from Jack. What does your workflow look like to ensure each panel and equipment matches the submittal? Do you use plugins that read spreadsheets to bulk edit equipment, or do you change each one by one?
So that would be you don't need a plugin to be able to do that. If you have a schedule within Revit that has all of the parameters, the shared parameters, you can easily pull the panel name, the length, width, height, and even if you have a checkbox that you've developed in there that says, let's say submittal verified, then all of that's there. And if that's integrated into your project template or your company template, then the families that you're utilizing already have that information in it, and whoever's responsible for that submittal verification can open that schedule and just do a quick yep, nope, yep, 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 nope, yep, and then make the changes. And more importantly is having that easy to reference check of, oh, this submittal's been verified. And then it'd be even a good idea to put your initials in there. So anybody that has a question say, oh no, Jared verified this, and I know this panel's good to go, or equipment in general, I should say.
Yeah, to the point that we were making earlier, is export that schedule out with your check boxes, have those heights, widths, depths in that schedule, pass it off to a PE and say, hey, go through our submittals, double check me here, get a second pair of eyes on it, have someone else look at it, and mark it up, redline it, show us where we need to correct it, and then go back in and make those adjustments. But yeah, it's a
Mhm.
lot of information to manage on your own. Get a
It
second pair
is.
of eyes on it.
Yep. And I'm like I said earlier, I'm not perfect by any stretch of the imagination, and I've done that. I've gone through submittals, and I said, "Yep, everything's good," and I missed some stuff, and it caused, unfortunately, a lot of rework, a lot of um, returns, and had to make a fast a fast pivot to a different type of light fixture.
All right. Do you got time for one more, Jared?
Yeah, I got time for one more.
All right. Victor, do you attach conduit to equipment or you just model up to it?
Mm. That's a great question. I've never been a fan of connecting the conduit to the equipment, because then if something needs to shift or change, especially if you have multiple conduit going into that same piece of equipment or JBox, it can cause some issues. I personally have just done alignment to it because then I can make those minor adjustments for unistrut, for center to center spacing, make sure that there's enough room between lock nuts, between conduit, edge of panel, or framework as well.
Couldn't agree more.
All right. Well, if no more questions, really appreciate everybody attending the webinar today. Hopefully, it was informational and you got something out of it. And like we said at the beginning, with the upcoming email with the recording of the webinar, we will also be sending out the checklist as well.
Thanks for joining, everybody. Jared, it was a pleasure. Great presentation. Really appreciate you putting it together.
Thank you, and everybody have a fantastic holiday, safe travels, and looking forward to continuing this journey.
Happy Friday, everyone.
Happy Friday.